So next we have Greg. Greg is in developer relations at OSO. He's worked in technology for nearly 30 years as everything from a software developer to a DevOps practitioner to engineering leadership. So I'll pass it on to Greg to start. All right, welcome, Greg.
Thank you very much. I'm really happy to be here. I am Greg. As I mentioned, I'm going to be talking today about authorizing LLM responses by filtering vector embeddings. So this actually touches on some of what Apoorva was talking about in the previous talk. I am from a company called OSO. We are an authorization as a service company. I'm a developer advocate there. So we, although not an LLM company specifically, we're a security and authorization company, and as such are very interested in the privacy and security implications of LLMs and chatbots and these natural language interfaces. So why are we here today? The main reason I'm here is I want to keep everyone out of the news, right? So no one wants to wake up in the morning and find out that they've leaked sensitive data. And one really good way to prevent that from happening is to make sure that you have good access controls in place. We'll get there by doing just a very brief overview of authorization, and we'll talk a little bit about how the authorization pertains to pre-trained LLMs, and then we'll get into the meat of the talk, which is going through the process of building up an authorized RAG chatbot, and we'll talk about how the authorization question gets to be a little bit more sophisticated and a little bit more subtle once we introduce Retrieval-Augmented Generation. And then we'll go into a couple of real-world authorization considerations after the sort of high-level chatbot concern to talk about strategies for dealing with authorizing chatbot responses. So what is authorization briefly? Everyone here, many people have probably heard both authentication and authorization. There's sort of the two primary terms that come up in access control. They're easily confused because they look very similar, they sound very similar, and they have a lot of domain. But essentially, authentication is simply the process of establishing your identity, right? You log in with a password, or you use a hardware token or OAuth or something, and establish to a system who you are. Authorization, then, once you've established who you are, is the process of defining what you're allowed to do. And so the two are closely intertwined. I can't authorize effectively without having authenticated you and knowing who you are. But that's the distinction. So authorization, what we'll be focusing on here, is that process of, after I've established my identity, how do I ensure that you get access to the things that you're supposed to have access to, and only those things. So how does this affect LLMs? Well, if you think back to sort of the early days of ChatGPT, there were some pretty high profile incidents that at their core were actually some authorization issues, right? So you may recall the Samsung data leaks that were happening with ChatGPT. And there was a whole sort of kerfuffle around the use of models like this in businesses, because what was happening is that ChatGPT was retraining itself on the prompts that people were submitting when they asked questions. So if I was working at a company and I had some questions about a sensitive project that I was working on, if I asked ChatGPT a question that incorporated data about that product, it would actually incorporate that prompt into its training models, which would then make that data available to future users of the system. This, for obvious reasons, was not something that businesses wanted to happen. And so a lot of businesses sort of reacted in a very draconian way by sort of reflexively blocking access entirely to tools like this. OpenAI, of course, would prefer that this not be the case. And so they introduced controls to allow business users to exclude their prompt data from the training sets, right? And in both of these cases, the real concern was that these businesses and people in these environments didn't want their sensitive data to be made available to other users of the system. This is sort of a classic authorization question. And the result of the process was the same in either way. we just prevented the data from making it into the training sets in the first place, either by preventing people from using the systems so that they couldn't provide the data at all, or later on when the controls were put into place, allowing certain sets of users to exclude the data from their prompts from those training sets. Although this is authorization, it's a pretty blunt approach to authorization. Right? You either make data available to everyone who is using the system, or you prevent everyone who's using the system from using that data. In this case, though, that's actually okay, and there are plenty of situations where a blunt approach to authorization is just fine. It's the experience of using, say, ChatGPT for the vast majority of users was not appreciably degraded by excluding some of this sensitive data from those prompts, right? And even the people from the businesses who were using it, probably for the most part, weren't expecting to get back detailed, sensitive, company data from ChatGPT. And so, putting this sort of very broad block on the data is fine in these sort of pre-trained scenarios. But what happens when we introduce retrieval-augmented generation? You've seen the introduction, I'm sure, in each presentation. I'll do another brief review of what retrieval-augmented generation is. Essentially, at a high level. Also, I was really happy to see Excalibur. I'm always pleased to see other people who use Excalibur on slides. It's so wonderful. In retrieval-augmented generation, when we're building a RAG chatbot, the query path, really, the question path changes slightly. So when someone submits a prompt, we can incorporate context from external sources into that prompt, and then we send that context along to the chatbot, and that allows the chatbot to provide a much more detailed and tailored response to the user. So you can imagine an internal chatbot, right, where you just ask sort of basic questions like, when are the holidays? How do I get to the office, right? And that could be just done as sort of a pre-trained chatbot. Maybe you train it on your company handbook, and it is able to generate responses based on published data in the handbook. But if you want people to be able to ask things like, how do I get promoted, say, or things that are a little bit more tailored to their individual experience, you want to be able to incorporate data from other sources, right? And so it would be one thing to just have your chatbot return the company HR guidelines and the standard career path, say, for that kind of a question. But it would be very powerful to be able to return to a person who asks how they get promoted, maybe results from their previous performance review, or conversations with notes from their one-on-ones with their manager where they talked about development opportunities, or even company chat with people on the team, asking them to take on more of a mentorship role or something like that. All of this would allow the chatbot to provide a much more relevant and specifically tailored response to this user to say, how do you get promoted, not just how would anyone in the company get promoted. So we'll dig in a little bit more detail into how that transformation happens, and this will start to sort of illuminate the authorization implications of this process, right? So when we're generating this context to provide to the chatbot, right, we'll have data from our primary data sources. Again, maybe it's a set of Notion documents, maybe it's documents in a Google Drive, maybe it's text from chats, but it's all plain text that we, as you've seen, chunk up, send it through an ETL pipeline of some sort that incorporates an LLM that converts the raw text data into vector embeddings. And then you store those embeddings in a database, and that allows us to perform similarity searches on prompts so that we can retrieve the most relevant context to a given prompt. So we've added a little bit more detail to the box and diagrams, and now we start getting a whole bunch of arrows and labels on here. But I've put together a couple of different flows to demonstrate these sort of two loosely coupled but intertwined processes that go into generating a query for an LLM chatbot and then retrieving the response. So the A, B's, and C's show the flow of data from primary sources right through the ETL, through an LLM that generates the vector embeddings and stores them in the vector database. And then now when our user submits a prompt, we send that prompt to the same LLM that we use to generate the embeddings, right? So that we can do an apples to apples comparison, send that off to the embeddings database and do a similarity search, and then return the response from the LLM with that included context. But this introduces a wrinkle, right? So, this is probably fine when our people are asking things like, how do I get promoted? But what happens if, say, someone asks a more pointed version of this question, like, why didn't I get promoted? Right? Maybe our user just had their review and it didn't go very well, and they're not happy and they're going to take it out on the chatbot. Well, now we have to be pretty thoughtful about how the chatbot responds, right? It can certainly return information like, oh, you've only been in the role for 6 months, and company policy is that you have to be in it for 18. So, maybe next year it'll go better. Or, the same sorts of information that you would get from your manager, say when you're having a review, the aggregated scores or summarized comments from the source. But what you don't want the chatbot to do is start divulging like personal information or individualized responses. If it has access to performance review data, it could very well take that source data and say, oh, well, in your last review, Alice said that you were terrible to work with, right? Or if you're using information from chat logs, say, you certainly don't want it maybe going into people's private chats and saying like, hey, the person who sits next to you really doesn't think highly of your hygiene, and they were on your review. Maybe if you clean that up a little bit, they'll have a higher opinion of you, and that will affect their thinking. So there becomes a little bit more. There's a little bit more thought that needs to be put into how the chatbot responds when you're making this additional individualized, tailored context available to it. So the sort of fundamental issue here is that initial data, the sources that you're pulling from have access controls on them, right? It's not just an undifferentiated mass of documents or a bunch of public channels in Slack or Teams or whatever the chat system of choice is. You probably have an HR folder that the HR department only has access to, but maybe they have a public policies folder off of that. You'll have a mixture of public and private channels in Slack. These access controls need to be honored after the transformation happens and when the chatbot is making responses. If in the process of converting that source data into vector embeddings, the ETL process strips the access control and it's no longer available when you're doing similarity searches, now you get this situation where someone asks a question about getting promoted and all of this sensitive information or embarrassing information gets leaked out. So I said at the beginning that this was about leaking sensitive company data and keeping people out of the news, and this isn't really, I'm maybe overstating the case here. I think this could be embarrassing. You might have someone have some hard feelings. You might have an awkward conversation that people have to have when something like this happens. But but someone getting some inappropriate information out of their performance review isn't going to get your company in the news, unless that person's perhaps really, really disgruntled, right? And the thing we have to keep in mind with chatbots is that they're interacting with people who are, we're all human, we're emotional, and sometimes we act out of anger. And if someone's had a really bad review and is going through a rough patch, maybe they take this a little farther. They ask why they didn't get promoted and start digging a little bit more when they find out that Alice said that they're awful to work with, and ask the bot what's Alice working on, and if it has access to that information, maybe they say, oh, it's the new top secret project. Ask for the specs for the top secret project, and then let's just burn it down on our way out the door, and put those specs on Reddit or Hacker News or whatever, and now you wake up in the morning and there's that headline that we wanted to avoid. And this is sort of a dramatized scenario here, but this is the sort of thing that can happen when you're working with a natural language implementation that is designed to respond to user queries and remember context and that sort of thing. And so this is why it becomes even more important to make sure that the source data isn't leaked out inappropriately when these sorts of things happen. So let's go back to the chatbot and think about how we can make this happen, right? So we're if you remember, we've got our user, we'll call him Bob. Bob didn't have a great review, unfortunately, and now he's asking the chatbot why they didn't get promoted. Well, the sort of fundamental problem that we need to solve is that when we ask this question and when we're doing this data transformation, as we mentioned before, at our data sources, at our primary source of information, we have authorization data, we have access control information there. We need to get it over here to the embeddings database, or at least have it somehow accessible to the embeddings database after passing through that ETL process. Right? One way that we could do this is you could just have separate embeddings databases, right? If you know that there's a bunch of source data that's available to the HR team, then you could have your embeddings LLM just store that in an HR database, and you can do the same for engineering, you could do it for finance, and you could have separate databases for each of the sets of, or each of the team's data that you have. And then at the point where someone asks a question to the chatbot, you just need to know what team that they're on, and you can ferry the response or the prompt to the appropriate embeddings database to ensure through sort of physical isolation that you only get back the context that person should be privy to based on what part of the organization they're in. Although something like this could basically work, we're just sort of back to the blunt approach that we were talking about with the pre-trained LLMs, except whereas in that case it was okay to do, and it was a reasonable approach to that problem. For a RAG chatbot, the needs are a little bit more subtle, and the authorization implications are a little bit more sophisticated, and this approach is too blunt to really be effective, right? It raises some questions like, what do we do with that public data that's in those public folders, right? Do you copy it to each of those individual databases? Do you set up a separate public embeddings database where all of the public embeddings are, and then you make sure that you query both of those two sources, the person's team and the public data? You're going to have some roles in the company that should have access to data that spans teams, your company leaders or the legal department maybe, or HR. And so do you have to query each of those individual embeddings databases to get all the relevant context for those people? However you approach those sorts of questions where the person, for whatever reason, spans a couple of different domains, we're also introducing a whole bunch of extra maintenance overhead. Right now we have n databases that we need to maintain, where n is at least the number of teams in the organization, and so that's that many more updates and backups and restores and things that can fail, and it's just a lot more overhead. And as was mentioned in the beginning, I have a lot of experience in DevOps and systems administration, and the less maintenance I can do, generally speaking, the happier I am. So what would really be effective is instead to just have one source of embeddings, but filter the responses at the time where someone asks the questions, based on the information that we have. And the good news is that this is in fact quite possible. So if we go back to the problem that we were talking about at the beginning, right, we need to make sure that our authorization data has some way of propagating from our data sources, our primary sources, to our embeddings database. The way that you do that, there are a couple of different ways to do it, but there are sort of two broad classes to approaching this problem, and they correspond to the two sort of broad classes of databases that we use to store these embeddings. Right? And so there are vector databases, which are sort of purpose-built databases that were designed specifically for the case of storing, retrieving, searching vector data. And these are things like Pinecone and Chroma, and their sort of reason for being is to deal with vector data. And then you have general purpose databases, just like the application databases that we all use to power our applications. Postgres and MongoDB are common examples that now have vector extensions that allow you to store and search on vector data right alongside relational data or document data or whatever the application data format is that you use in your organization. If you're using a vector database, then there are mechanisms whereby you can associate that authorization information or just any metadata about a given vector to create sort of a loose coupling back to the application database. Right? There are embeddings databases that allow you to store JSON, arbitrary JSON, as metadata with your various vector embeddings. And so you could envision in your ETL process passing along like what the block ID was or what folder something was in, the access control information that applies to that vector. And then you can sort of loosely couple it back to the application database to get back any other additional context that you need in order to make a decision about whether a given user has access to this specific vector. If you're using a general purpose database with vector extensions and you're using the same database that you use to store your application data, then you can just store those embeddings in the same database as your application data, and then you can make a tighter coupling between application data and vector embeddings, where now, if the vector embedding here is associated with a block in the blocks table, then you even have a foreign key relation between the two if you wanted that tightly couples them. And then you can write queries that go back out and determine which teams have access to something based on the folders that they're in. And this creates a situation where you can actually write an authorized query to return just that data to your user that is both similar to the prompt and is in the set of data that they're allowed to have access to. So obviously this is a very pseudocodey query, but you can envision a query where you're selecting the relevant context from your embeddings for this user, where the folder that stores that data is in a list of folders that the user can access, for instance. If once you have something like this in place, now we actually have what we need. We have the information that we need in order to make the kind of evaluation that we need to make. The hitch is to make sure that we are propagating that authorization data through our ETL pipeline, storing it in whatever mechanism, or associating it with the vector data through whatever mechanism our database provides. But the key is to make sure that authorization information is associated with the vector. And now we're done. When someone asks a question, we can provide an authorized response, because we can authorize the data that comes back from the embeddings database and make sure that only those bits of information that our user should have access to gets sent along with the prompt. So this was easy. We're done. Nothing left to do. Except in reality, we find that this isn't actually as straightforward as all that. And this is where as kind of a group that deals with authorization a lot, even writing this as sort of a pseudocode query felt a little hand wavy to me while I was going through it. You very seldom have just a nice clean list of folders that someone can access as your authorization logic or that sort of thing. In reality, you much more frequently see something like this, and even this is somewhat simplified, where if I want to figure out what folders or what data this person who is making the query has access to, I need to know all these things like, is this user the person who owns the folder, or are they on the team that owns the folder, or maybe the folder is public, so that allows them to see it, or maybe the document is public, or maybe we've shared that folder with a bunch of users who aren't in the team, but this user is a member of that list, but we don't want to show archive data, so let's exclude that from the set. And you sort of end up with these kind of thorny queries or functions that sort of explode in length. But if you look at this, the majority of the logic here actually has nothing to do with the similarity search. The majority of it's just authorization logic. And so we run into a lot of people who have this issue when trying to answer these sorts of questions, and it becomes kind of a pain because now your code looks like a mess, but it doesn't need to be a mess because most of the mess is just authorization's fault. So when this happens, one thing that a lot of people start to do is to sort of externalize that authorization logic. You can move it into a separate function. You can move it into a separate module in your application. Sometimes you can also just use a dedicated service. Some people write their own services. Obviously, I work for a company that does this, but the key is to, one way or another, externalize that authorization logic from the actual application logic or the comparison logic, so that it doesn't become unwieldy to maintain the two. And now it becomes easier to reason about the similarity search, and it becomes easier to reason about the authorization side of things. this might seem like nonsense because we're saying, oh, let's just throw in another service to deal with authorization. But if through whatever mechanism you do kind of separate these concerns, you do complicate, the evaluation path a little bit. Now when our user asks, what a question, Bob wants to know why he didn't get promoted, we're deferring to some externalized authorization logic or an external service to ask, hey, what are the things that Bob is allowed to access? The authorization service returns to our chatbot that list of things, and then we can send that along to the embeddings database as part of the similarity search. That hey, only return those similar things that are in this set of things that the authorization service says Bob is allowed to access. But having done that, if we externalize that logic, kind of a funny thing can happen. That complicated query where all of this authorization logic is embedded in the actual query can actually reduce back down to the sort of hand-wavy version that we were talking about before by deferring the evaluation of the authorization query to some external source of logic. There is, as there always is in this talk, a hitch to this sort of thing. By deferring this evaluation to an authorization service, we've just recreated the authorization data problem that we had in the first place, right? Like we managed to get all that work to get authorization data over to our embeddings database, and now that's not good enough because the embeddings database isn't involved in the evaluation of authorization, which is good from a separation of concerns perspective, but it's bad from a data perspective, right? We need to get that data over here to the authorization service, otherwise it's not going to be able to make this evaluation. There are a couple of ways you can do this. You can basically centralize that data in your service, and you basically have a two-phase commit now, right? Every time someone changes something that affects authorization or our ETL pipeline, changes and we need new authorization data, we need to get that into the embeddings database, especially if that embeddings database is co-located with our application data, because you're probably using that data for other application logic. And then it also needs to make it to the authorization service. And so we have this sort of classic two-phase commit problem where now we have to detect and remediate drift. But on the plus side, the authorization service can answer these questions for us. On the flip side, you can just keep the data in your application database, and the authorization service now, rather than just saying yes or no in response to a question about does Bob have access to this data, or providing the list of things that Bob has access to do, you can configure the authorization service so that it knows how the application needs to answer that question. And basically, you can ask, what are the things that Bob has access to? And the service can return sort of a partially evaluated response that instructs the application and says, hey, Bob has access to any blocks that are in folders or in documents that are in folders that are owned by his team or that are in public folders. It's up to you to figure out how to answer that question at the database. Or you can provide a crafted query that the application can then use to evaluate that decision. And this way we get sort of a two-phase authorization response where the application asks the service the question and the service tells the application how to answer it for itself. And so given that, now we actually do have something that does what we wanted it to do. We can authorize these responses by deferring those questions to an authorization service, and then authorize at the authorization service and get our filtered responses back from the embeddings database. If this has piqued your interest in authorization, we have an Authorization Academy. This is a vendor agnostic introduction to authorization, actually more than an introduction. It goes very deeply into authorization topics, different models, where you would apply them, how you can construct authorization code in your application, strategies for externalizing authorization logic. Really encourage anyone who has had their interest piqued in this domain to check that out. It's a great resource. And other than that, thank you very much for listening to my talk.